So the basic principle of how this works is that the transmitter will release ultrasonic sound waves. Now some of these waves will hit an object and will be reflected, and some of these reflected waves will be picked up by the receiver. Now for the amount of time that these waves are detected by the receiver, the echo pin will be set to high, and the amount of time that the echo pin is high for will be sent to the Arduino. Now, we are trying to work out the distance, and as we know, distance is equal to speed times time. We already know that the speed of a wave is 340 meters per second, approximately. And now we know that the time that we need is given to us by the Arduino. So all we need to do is tell the Arduino to multiply those two values together, and importantly, because we're looking for the distance of the object, we've got to remember that the distance being calculated is the distance it takes for the wave to be sent and the wave to return. We need to make sure that it's in the code to divide the distance by 2 in order to get the true distance of the object. For this build, you'll need an Arduino, a breadboard, an ultrasonic sensor, a micro servo motor, and jumper wires. Start by connecting the 5V pin of the Arduino to the positive power rail and the ground pin to the negative power rail to supply power to the breadboard. So there can be different wire color combinations depending on which servo motor you use. So here the red wire is positive, the brown wire is negative, and the orange wire is a servo control signal line, and it's used to give it instructions. So you want to connect the orange wire to pin 12 of the Arduino, connect the red wire to the positive power rail, and the brown wire to the negative power rail of the breadboard. So now on the ultrasonic sensor, connect the VCC pin to the positive power rail on the breadboard, and connect the ground pin to the negative power rail. This will power the sensor. So now you want to connect the trigger pin to pin 10 on the Arduino, and then connect the echo pin to pin 11 of the Arduino. So now I'm going to attach the ultrasonic sensor to the plastic base that comes with the servo motor. Then I'm going to place it on the servo motor where it should click into place nicely. So now we're going to plug the Arduino into our PC. And now you can see here in the code that pin 10 is assigned to the trigger pin and that 11 is assigned to the echo pin. And you can also see that pin 12 is also assigned to the servo motor, just like how we set it up. So you can upload that code, and once that's done, what you'll notice is that the motor will start to oscillate. Okay, now we need to do the display. So first of all, you want to download a software called Processing 4, and then you can stick this code into it. Just one thing to be aware of is that on line 19 you might have to manually change the COM number value to whichever port on your PC that your Arduino is connected to, because the default value in the original code might not be the same, so I had to change mine to COM3 manually. So when you're good to go, you can press run, and then you should see the display. So as you can see in this side by side, the Sonar device can now detect the angle and the distance of any object in its way within about 40 centimeters and display it on the screen. I had a slight issue with the motor that's rotating from the base, but temporarily I fixed it by placing it in a box. Later on I glued it to an old headphone speaker base just to stabilize it. And that seemed to work. So I hope you enjoyed. If there's anything I could have done better, or if you have any ideas for a build, please comment down below, and thanks for watching.